So once we're satisfied with the backbone and side chain geometry that we've generated with Primex, we can place our ligand. In order to do so, we need two important prerequisites to be fulfilled. First, we need to import our ligand structure into Maestro, and second, we'll need to have a difference map associated with the protein structure. First, to import the ligand from a PDB file, we click on the Import button in the Maestro toolbar. In the File Import dialog, we set the file type to PDB, choose the ligand file, and click on Import. When we close the Import panel and look at the project table, we can see that the ligand entry is here at the end of the table. To display the difference map, we can right-click on the S button in the surface column for our protein and choose FO-FC from the list of previously calculated maps. Remember, we can generate density maps simply by clicking the appropriate toggles under the Maps tab in the interface used to set up reciprocal space refinements. In this example, the difference map was previously calculated as part of a reciprocal space minimization, and we want to make sure that we're only looking at the difference map in the region of displayed atoms. We can do this by clicking on the S button in the surface column for our protein, which brings up the surface table, where we see that the difference map is currently displayed in the workspace. First, we'll disable the Display at Most toggle, which will cause Maestro to show the entire difference map. To limit the difference map solely to the volume around atoms in our protein, we'll click on the Limit button to open the Limit panel, and then click on the All button to select all atoms. Because the distance setting in the limit panel is 2 angstroms, the result is that we only see the portion of the difference map that lies within 2 angstroms of any protein atom. We'll increase the distance setting to ensure that we're visualizing electron density that corresponds to the ligand atoms we haven't yet placed in the active site. The red contours in the difference map are negative difference features, regions that correspond to either noise or a region where something has been placed that shouldn't be there. The blue regions correspond to positive differences, regions in which water molecules or the ligand might be placed. In this example, the largest contiguous region of positive difference corresponds to the region where our ligand should be placed. To place that ligand, we'll click on the Select a Task button from the Primex toolbar and choose Ligand Solvent Placement. The Ligand and Solvent Placement panel contains a number of predefined ligands, but proprietary ligands probably won't be found here. Instead, we'll choose the ligand that we imported into the project table by clicking on the Choose button here to open up a selection dialog, and we'll highlight the ligand from the list of all entries in the project table. Clicking on the Choose button in the ligand selection dialog will confirm our choice. When running a ligand placement job, there are a couple of options to take note of. The first is Prepare Ligand with LigPrep. Checking this box will ensure that the backend takes into consideration the most likely protonation state on the ligand when placing it. Remember, Primex uses an all-atom force field, so it's important to ensure that you're working with the correct ligand protonation state. The other option to take note of is Refine Poses. Selecting this option will tell Primex to follow the ligand placement with a real space refinement calculation, which tends to improve results. And finally, we need to tell Primex which electron density peaks to pay attention to when placing the ligand. First, ensure that the Pick Peaks toggle is highlighted. Then, in the workspace, click on the spheres that correspond to electron density peaks. In general, it's better to select too many peaks rather than too few. The red spheres correspond to the highest electron density peaks, and the blue spheres correspond to the lowest. As we click on the peaks, we notice that a purple box appears in the workspace. This box is centered on the center of mass of the peaks that we've selected, and it represents the confining box into which the ligand will be placed. The size of this box is determined by the size of the ligand that we just selected. Finally, to run the calculation, we click on the Start button and submit the job. At the conclusion of the job, the results, which include several possible ligand poses, are incorporated into the project table and appear in the workspace. In this example, the top-ranked ligand pose has a good density fit, and in the project table we can find ligand R values and other metrics to help us gauge the ligand placement results. One thing to be aware of is that we may wish to fine-tune the ligand placement by performing a rigid body refinement, which can be done using the reciprocal space refinement panel.